Hello, my name is Neil Lilly and I'm with Lilly Engineering and I'm here to discuss the features and benefits of the Z-Disc control valve. A while back, a major brewer approached us and asked us to design a control valve to fit their needs. They were utilizing a standard globe style control valve. That valve was getting to be too large for their aging plants, too heavy, and too expensive. I approached a friend of mine, Dr. Hans Baumann, the holder of over 200 control valve patents and the author of the ISA manuals on control. I explained to him their situation, and he recommended that we use a resilient seated butterfly valve. The reason being is it's a solid platform and that any given brewery can have 2,000 to 3,000 of these valves in their system. The issue is getting it to behave like a globe style control valve. Most people understand that you cannot control with a butterfly valve, but they don't necessarily understand why. It's very simple. The reason that you cannot control the butterfly valve is because the area of a circle is pied r squared. When you take a standard disc from a butterfly valve, you can see that if you make a small movement with the disc, that r squared becomes a very large number or a very small number very quickly, thus giving you no control. The second issue is that you've got a disc in your fluid and the velocity on one side is greater than the velocity on the other, and it becomes a wing. It wants to flutter in your fluid. As you flutter in your fluid, you are playing with that r squared again, thus giving you no control. The third issue is that when you go to seat your disc into your seat, it's a friction seated valve, so you jam it in there. You get beautiful tight shutoff. When you go to open this, your actuator is saying open, 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 and it pops. And as it pops, you have no control on your low end of your movement. We introduced the Z-Disc control trim. What we've done is we've modified the disc so that it will be able to control that area of the circle. As you can see, we have a geometry on our disc edge that enables us to give us the control required of that area. This disc will give you what they call equal percent flow characteristic, the holy grail of control. So we can get control throughout our entire movement. The next issue, as I had said, was preventing the disc from fluttering. Inside of our Z-Disc, we have a recess on both sides of our disc. This recess breaks the vacuum, which prevents it from being a wing. It no longer will flutter. So now you have a steady element in your fluid. The third thing is, because of this geometry, we are tapered going into our seat. By going into the seat very softly, we can come out of the seat very, very smoothly and give us control throughout our range. As you can see, this 4-inch control valve, I can open and close it and give you a Class 6 shutoff just by using 2 thumbs. I come out of the seat very softly, and now I have complete control throughout the range. I thank you for your time, for listening, and if you have any questions, please contact Lilly Engineering.